Good evening, everyone. A very good evening to all of you, bachcho. We are live. We are back in the rank improvement course on EMFT. The next session, that is magnetism, or you can say magnetostatics. So till now, beta, whatever I have discussed about the electricity or the electrostatics. And now is the time that we start discussing about magnetism. But before I start magnetism, let us review what we covered in the previous lecture. We covered the concept of potential difference, which is the work done per unit charge. It is independent of path for an electrostatic field. It is integration A to B minus E dot dl. While defining the potential, we take the reference as infinity, where the potential is 0. Potential due to point charge is Q by 4 pi epsilon r. So for point charge, Q by 4 pi K epsilon r, K is the dielectric constant. Or do one thing, take 4 pi epsilon r. For conducting sphere, if you take inside, the potential is same as on the surface of the sphere. Outside, same as the point charge. This also I derived in the previous lecture. Uniformly charged insulating sphere, and outside again same as that of a point charge. ये भी मैंने आपको derive करके दिखाया था ना, 3q by 8 minus q by 8. Okay. Now beta, electric field is minus gradient of V, where gradient is written like this: del V by del X, del V by del Y, del V by del Z. Potential energy of the system was summation half Qi Vi, where Vi is the potential at the location of Qi because of all other charges. For continuous charge distribution, half triple integral d dot E dV. So half d dot E is called as energy density, which is half epsilon E square. Capacitance was Q by V. For parallel plate, epsilon A by D. For cylindrical, 2 pi epsilon L upon log B by A. For spherical, 4 pi epsilon AB by B minus A. For isolated sphere, 4 pi epsilon R. For series, you combine the reciprocal of the capacitance. For parallel, they are directly added. Energy is half CV square or Q square by 2C or half QV. Okay. Dielectric is the insulating material with bound charges. When we apply electric field, all the dipoles get aligned in the direction of electric field. Polarization vector is epsilon naught chi E into E. Okay, where chi E is the susceptibility, which represents the tendency of a material to become polarized. The relative permittivity is 1 plus chi E. Because of dielectric, the capacitance increases by a factor of epsilon r. When the dielectric interface is taken, tangential component of electric field is same in both the dielectric, and normal component of flux density is same. Flux density is epsilon into E. At the interface of dielectric and conductor, tangential component of E is 0 and normal component of D is sigma S, which is the surface charge density. And this is the relation tan theta 1 by tan theta 2 when sigma S is 0. Theta is the angle of E with respect to normal. Normal के respect में कितना angle है? Theta 1 and theta 2. Now, method of images, this can be used to replace the infinitely long conducting plane. So, whenever a charge is kept near a infinite plane, we replace it by the image charge. It has the same magnitude, opposite sign, same distance as the original charge. So this will help us in finding the potential and the electric field at the point of interest. This is the Poisson equation, where rho v is the volume charge density. In charge-free region, this is the equation which is known as Laplace equation. Now, Laplacian operator I have already told you in different coordinate systems. Ohm's law is J equal to sigma E. Continuity equation del dot J is minus d rho v by dt. relaxation time epsilon by sigma. So charge density decays exponentially with a time constant equal to relaxation time. Power density is J dot E, which is sigma mod E square. Okay. So for energy, use the potential. For force, use the electric field. For capacitor, correctly identify the series parallel connection. For interface problem, remember the boundary condition. Laplace-Poisson equation are used when potential is given at different value of coordinates. Okay. Image method will simplify the problem where there is a infinitely conducting plane, and relaxation time will tell you how quickly the charge decays in a conductor. Okay. Clear hai bhai? In my preparation, sir, I am getting 16 timed mocks and PYQ papers 75 plus, just maths and EMFT remaining. Should I cover EMFT? Beta, you can cover EMFT with the help of crash course, and even maths, if you have a basic concept, you can cover with the crash course. Crash course is available on this channel. Okay. Is it important like weightage is not good? Beta, magnetism and electrostatics have almost the same weightage. If you don't have time, you can choose one of them, but actually in the exam they have similar weightage. अब बताइए भाई, और कोई डाउट है? और किसी का कोई डाउट है भाई? बोलो जल्दी से. Anybody having any doubt in whatever we have covered so far? Shall we move ahead? Shall we move ahead बच्चों? चला जाए आगे. चलिए. So what is magnetostatics? Magnetostatics is the study of static magnetic field, which means the magnetic field does not change with time. Yes, it can vary with the coordinate x, y, z, but it should not change with the time. That is the magnetostatics. Now, what are the important properties of magnetic field? Magnetic field is solenoidal, so the divergence is zero. Actually, the word solenoidal has originated from magnetic field only. The pattern of magnetic field is such that its divergence is always zero. So we say whenever the divergence of any vector field is zero, it is similar to a magnetic field and we call it as solenoidal. So first of all, magnetism was discovered by Oersted, who discovered that whenever a current carrying conductor is there and you place the iron fillings all around it, then the iron fillings, iron का जो चूरा होता है उसे iron fillings कहते हैं, they are arranged in the circular pattern similar to their pattern near a magnet. So we say a current carrying conductor behaves like a magnet. अगर आयरन फिलिंग्स को मैग्नेट के नजदीक रखो तो जिस तरह से वो सर्कुलर पैटर्न में अरेंज होती हैं, वैसा ही कुछ तब भी देखा जाता है जब इसे एक कंडक्टर के पास रखा जाता है. तो एक कंडक्टर एक मैग्नेट की तरह बिहेव करता है. तो रिमेंबर, whenever you talk about the magnetic field, a current carrying conductor produces a magnetic field. And beta, the direction of current is very important in deciding the direction of magnetic field. But current is a tensor quantity. We cannot treat it as a vector, right? So we take a element dl. dl is the small length on the current carrying wire whose direction is same as the current direction. So it will behave like a vector. अब करंट को तो वेक्टर नहीं बना सकते ना, उसकी डायरेक्शन डायरेक्टली यूज नहीं कर सकते. तो करंट के डायरेक्शन में मैंने एक छोटा सा dl ले लिया in and then I into dl vector. This will become a vector. It is known as the current element. I into dl vector एक वेक्टर बन जाएगा जिसको मैं करंट एलिमेंट के नाम से जानता हूं. The unit is ampere meter. Okay. Then beta, what are the various sources of magnetic field? First is simply the current carrying wire. In a current carrying wire, in order to use the direction of current, as I told, take a small length dl. Okay. The direction of dl is tangent to the wire. So it is known as dl vector. So I into dl vector becomes the current element. The unit is ampere meter. It has the same direction as the current. ठीक है, I dl vector current element कहलाता है, यूनिट एम्पियर मीटर होती है. और डायरेक्शन करंट वाली ही होती है। सेकेंड इज द सरफेस करंट। सरफेस करंट बेटा यूजुअली वी कैन सी बिकॉज ऑफ द स्किन इफेक्ट, है ना। इन इलेक्ट्रिकल वी नो देयर इज अ कॉन्सेप्ट कॉल्ड स्किन इफेक्ट। तो व्हेन यू हैव अ इनफिनिट कंडक्टिविटी मटेरियल, जब आपके पास एक ऐसा मटेरियल हो जिसकी कंडक्टिविटी इनफाइनाइट है, एंड व्हेन यू पास एसी करंट थ्रू द मटेरियल, द करंट रिफ्यूजेस टू penetrate inside the conductor, it only flows at the surface of the conductor, then it is called surface current. जब आपके पास एक ऐसा मटेरियल होता है जिसकी कंडक्टिविटी इनफाइनाइट होती है, तो करंट उसके बल्क में जाने से इनकार कर देता है, सिर्फ उसकी सतह पे फ्लो करता है, और वो करंट कहलाता है सरफेस करंट। So in magnetism we use the surface current density, which is written as K. The unit is ampere per meter. So when you take KdS, it will become a current element ampere meter. ds is the area. So ampere per meter into meter square, it will become ampere meter. समझे? surface current माने the current is only flowing at the surface of a conductor, not flowing inside the conductor. Last is volume current, which is the most commonly seen type of current. Even if you have wire beta, current will flow inside the wire. That is known as the volume current. The volume current density is ampere per meter square. So when you want to make current element, multiply it by volume. So when you multiply it by volume beta, it will become ampere meter. How? एम्पियर पर मीटर स्क्वायर इंटू मीटर क्यूब। तो तीन तरह के करंट देखे जाएंगे बेटा जब मैग्नेटिज्म की बात होगी, लाइन करंट, सरफेस करंट, वॉल्यूम करंट। वी विल डिस्कस अबाउट मैग्नेटिक फील्ड ऑफ थ्री ऑफ देम। ठीक है, तीनों के मैग्नेटिक फील्ड पे चर्चा होगी। एसके जोन भाई देखो, तुम्हारे कॉलेज से कौन बच्चा कहाँ प्लेस हुआ, वो उतना पढ़ने वाला था नहीं था, उतना काबिल था नहीं था। तो देखो यार, हर बंदे की अपनी जर्नी, एक अपनी ट्रेजेक्ट्री है। और अगर हम इस चीज पे कंपेयर करने लगे ना कि लाइफ में किसको कितना मिला और कब मिला, तो सही बता रहा हूँ जीवन बहुत डिप्रेसिंग हो जाएगा। हर किसी की अपनी राह होती है, अपना डेस्टिनेशन होता है और अपनी ही मेहनत होती है। तो आपकी एक अपनी ट्रैजेक्टरी, आपकी अपनी एक डेस्टिनेशन, आपकी अपनी एक जर्नी है, उस पर फोकस करो। उसमें अच्छा करोगे तो जो चीज आप अपने लिए सेट करोगे वो आपको मिलेगा। अब आप किसी और की सक्सेस देख के, जो टारगेट शायद आपका था भी नहीं, वो उसने अचीव कर लिया, उसको देख के हम परेशान हो रहे हैं। जिस चीज के पीछे हम भाग ही नहीं रहे थे वो किसी और को मिल गई, इससे फर्क क्या पड़ता है? हम जो चीज चाहते हैं हमें वो मिलना चाहिए ना, जो चीज हम नहीं चाहते उसे लेकर के भी क्या करेंगे। चलिए, नाउ व्हाट इज मैग्नेटिक फील्ड इंटेंसिटी एंड मैग्नेटिक फ्लक्स डेंसिटी? जस्ट लाइक इन इलेक्ट्रिक फील्ड इंटेंसिटी आई टोल्ड यू, whenever there is a charge present, there is the influence of the charge in the region around the charge. उस चार्ज का असर महसूस होता है चार्ज के आसपास। Now because of that, what happens whenever there is influence of charge near the charge, that is known as electric field, and how much is the influence is known as the field intensity. So due to that, what happens whenever there is another charge nearby to the original charge, it experiences a force. Similarly, there is a region around a current carrying conductor in which you can experience the influence of the conductor, that is magnetic field. And how strong the influence is, that is the magnetic field intensity. It is written as H vector. The SI unit is ampere per meter. Now, what is the magnetic flux density? It is the number of field lines that will be passing normally through an area. It is known as the magnetic flux density. The number of field lines passing normally through an area per unit area is known as the flux density, written as B. So in electrostatics, you have D and E. D is the flux density, E is the electric field. In magnetism, you have flux density as B and magnetic field intensity as H. So there D equal to epsilon E, here B equal to mu H. Okay. Mu is called permeability. So permittivity is the opposition to the passage of electric field, while permeability is the allowance to the passage of magnetic field. Permeability is mu naught into mu r. Mu naught is the permeability of free space, 4 pi into 10 ki power minus 7, which is the unit is Henry per meter. Mu r is relative permeability. So we come to the first law of magnetism, Biot-Savart law. So Biot-Savart law helps in finding the magnetic field due to a current element. So I take a current element dl. This is the direction of the current element. From this current element, the point where I want the magnetic field is at a distance r. जहां मुझे magnetic field चाहिए उसका distance है r, and the position vector of that point makes an angle theta with the current element. Current element की जो direction है और उस point का जो position vector है, इसके बीच का angle theta है. So Biot and Savart were two scientists. What did they discover? That the magnetic field is proportional to current element. The stronger the current element, more magnetism it produces. Inversely proportional to r square, just like Coulomb's law, the magnetic field is inversely proportional to square of distance and directly proportional to sine theta. Theta is the angle between dl and r. So they combined all these factors and wrote I dl sine theta by r square. The proportionality constant was experimentally found out as 1 by 4 pi. So this was dh. Now, how to write dl sine theta? It can come from the cross product. So they wrote dl cross r cap. R cap can be written as r vector by r. So it will become r cube and this will be r vector. So r is what? R is the position vector of the point with respect to the current element. Current element से उसका position vector है. So now beta, if it is a line current, you will take the line integration. If it is a surface current, you will do ds k cross r. K is the surface current density. If it is a volume current, you will do j cross r dv. J is the volume current density. So that is how they propose to find the magnetic field. So the direction of magnetic field depends on the cross product dl cross r. So here if you see, this is dl, this is r. So dl cross r, magnetic field is inwards. अंदर की तरफ आएगी. Okay. So right hand thumb rule tells you how to find the direction of magnetic field. If the current flows in a straight wire, okay, then hold the wire. Suppose this is the wire. Hold the wire in your right hand with the thumb in the direction of current. Then curl of the fingers will give you the direction of magnetic field. Thumb आपका current के direction में आएगा तो fingers आपको magnetic field बताएंगी. If current is flowing in a circular loop, then curl the fingers in the current direction. Thumb will give you the direction of magnetic field. कर्ल करिएगा फिंगर्स को बेटा एंटी क्लॉकवाइज करंट के डायरेक्शन में, थंब से आपको मैग्नेटिक फील्ड मिलती है. So for straight conductor, hold the conductor in the right hand with the thumb in the direction of current. The rotation of fingers tell you the pattern of magnetic field. If it is a circular conductor, curl the fingers in the direction of current. Thumb gives you the magnetic field. Otherwise, you can use Fleming's right hand rule. In the right hand, the first finger is current element. The second is R vector. The third is the magnetic field. But sir, this is flux density. Actually, flux density and magnetic field have the same direction. So this is for the long straight conductor I told. Okay, for circular, the fingers in the current direction, thumb is the magnetic field. Okay. Now beta, just like we had a finite line charge, here we have a finite line current. In the direction of current beta, the angle made by the first end is theta 1. we are taking a line current at the z-axis, the point in the xy plane. The position vector of point will be rho. So rho is the perpendicular distance of the point from the line current. I told you in electrostatics also how to take perpendicular distance. If the wire is along z-axis, perpendicular distance is taken using xy coordinate. If the wire is along x-axis, perpendicular distance using yz coordinate. If the wire is along y-axis, perpendicular distance using x and z coordinate. So this is the perpendicular distance. Now the angle of the lower end with respect to rho is theta 1. The angle of the upper end with respect to rho, theta 2. Lower end का angle theta 1, upper end का angle theta 2. So H vector is I by 4 pi rho. Rho is the perpendicular distance from the wire. Sin theta 2 minus sin theta 1, A phi cap. ठीक है, A phi cap. Perpendicular distance from the point from wire. Okay. Now, if the one end of the angle is below the xy plane, that is in the negative z, so theta 1 will be negative, so minus minus plus. Semi-infinite, if one angle is 90, other angle is 0, so sin 91, sin 0, 0, so I by 4 pi rho. Infinite wire, if one angle is 90, other is minus 90, one is at plus infinity, other is at minus infinity, so sin 90 minus sine of minus 90, it will be 2 I by 2 pi rho. This is the case of infinite wire. Okay? So you remember the case of finite wire. This is very, very important. And this also. Rest of the cases are not very important. Okay. Now a polygon is basically composed of multiple finite length wire. So when we find the magnetic field at the center of a polygon having n side, it comes as Ni by 2 pi rho sin pi by n. Ni by 2 pi rho sin pi by n. Rho is the perpendicular distance of the center from the edge. If you see, this is the edge. Rho is the perpendicular distance of the center. For circular loop, it becomes I by 2 rho. You can say a circular loop is a polygon having infinite number of sides. So as n tends to infinity, 1 by n will tend to 0 or pi by n will tend to 0. So sin theta by theta limit will become 1. समझे? एक सर्कल को आप ये कह सकते हो कि ये भी एक पॉलीगन ही है, लेकिन इसके कितने साइड्स हैं? इनफाइनाइट साइड्स हैं, जिसका मतलब 1 by n टेंडिंग टू 0 आता है. What is the magnetic field on the axis of a circular loop? Mu naught n I r square 2 r square plus x square to the power 3 by 2. R is the radius, x is the distance along the axis, n is the number of turns. N is the number of turns. What is the magnetic field due to an arc of a circular loop where the arc has an angle theta? अगर एक पूरा सर्कल नहीं है, एक आर्क है, तो म्यू नॉट आई थीटा by 4 pi r, where r is the radius, theta is the angle. ये जो I by 2 रो है ना, ये एक टर्न के लिए आपके पास आ रहा है. ठीक है, ये जो I by 2 रो है, दिस इज ओनली फॉर वन टर्न. यहाँ पे एक ही टर्न है. ये वाला फॉर्मूला n टर्न्स के लिए यहां से भी I/2R निकाल सकते हो. Just you have to keep x equal to 0, है ना. In this formula, putting x equal to 0 gives the value of flux density at the center of circular loop of having n turns. Having n turns. So now beta, whenever a circular coil produces magnetic field B at a center, now if you fold it into n turns, the magnetic field because of same current becomes n squared times. Magnetic field at the center is 0 in the following cases. It is a straight wire, then a circle, then another straight wire. In this case, magnetic field at the center is 0. Okay, in this case also the magnetic field is 0. This case also magnetic field is 0 because the two parts of the semicircle will cancel the magnetic field. ऐसी situations में magnetic field आपका 0 देखने के लिए मिलता है. ठीक है. Is that clear to everyone? तो यहाँ पे भी क्या है कि current will be divided into two parts. The magnetic field will be 0. Current will be divided into two parts. The magnetic field will be 0. Current will be divided into two parts. The magnetic field will be 0. ठीक है. Next is the Ampere's law. Just like we have Gauss law for electrostatics, which uses the symmetry to find the electric field. Similarly, Ampere law uses the symmetry to find the magnetic field. So Gauss law suggested we take the surface integration of flux density, which will be equal to the charge enclosed. Ampere's law suggested that you take a closed loop. आप एक closed loop लीजिए. This is known as the Amperian loop. Okay. Just like for Gauss law, you have Gaussian surface, which is a closed surface. In Ampere's law, you have a closed loop called as Amperian loop. You take the line integration of magnetic field along this closed loop. It will come out to be equal to the current enclosed. Current enclosed माने the current that crosses the loop. करंट जो लूप को फाड़ते हुए जाता है, करंट जो लूप को कट करते हुए जाता है, it will be equal to the current enclosed. Okay. So the closed curve along which you are applying the Ampere's law, you have to choose it such that the H direction and the DL direction, that is, H should be tangential to the Amperian loop and the value of H should be same at all points on the Amperian loop. जैसे गॉस लॉ में आपने बोला था चूज गॉसियन सरफेस सच दैट वैल्यू ऑफ D is same at each point of the Gaussian surface and D should be perpendicular to Gaussian surface. Similarly, choose the Amperian loop such that H is tangent to the loop and value of H is same at each point on the loop. So how to take the current? First of all, in the loop, take the currents which are passing inside the loop. The currents outside the loop, yes, they also produce magnetic field, but closed loop integral H dot dl because of the currents that are outside the loop is 0. जो करंट लूप के बाहर लाई करते हैं उनसे H dot dl 0 आता है, वो सिर्फ अंदर वाले करंट से आता है. Now if the current is upward, the magnetic field will be anti-clockwise in the direction of the loop. So this current will be positive. So upward will be positive. Okay. And downward will be negative. So the current that produces a magnetic field in the direction of loop will be taken positive, and the current that produces magnetic field opposite to the loop, it will be negative. Okay. Amperian loop is anti-clockwise. So the current for magnetic field anti-clockwise should be upward. Current direction must be upward for anti-clockwise magnetic field, that is H parallel to dl vector. लूप के पैरेलल मैग्नेटिक फील्ड बनाने के लिए करंट अपवर्ड होना चाहिए, तो अपवर्ड वाले को पॉजिटिव, डाउनवर्ड को नेगेटिव. सो आई विल से H डॉट dl इज I1 प्लस I3 माइनस I2. I1 प्लस I3 माइनस I2. ठीक है. So the differential form of the Ampere's law, just like there was differential form of Gauss law, del dot D is rho V, it is del cross H equal to J, where J is the volume current density. This is point form or differential form of the Ampere's law. Now Ampere's law will be used wherever there is a symmetric current distribution, like a current carrying wire, where current is uniformly distributed inside the wire. So what is the current per unit area? It will be I upon area. So I upon pi a square. That is the current density. Now if I choose a Amperian loop inside the wire, the radius of the loop is r less than a. How much current passes through the loop? Current density into pi r square. So current density into pi r square, that is I into r by a square. Now I will apply Ampere's law. H dot dl. H will be same at all point on the loop and parallel to the loop. H हर point पे बराबर है और parallel है, तो H comes outside the integration. Integral dl is circumference of the loop 2 pi r. This is the current enclosed. So H is IR by 2 pi a square. That is proportional to r. That is proportional to r. If I take a Ampere loop outside the cylinder, then the current enclosed is same as the total current I. Total current I. So H dot dl is current enclosed, which is total current I. Now H is same at all points of the loop, so it can be taken outside. Now again integral dl is the circumference 2 pi r. So H is I upon 2 pi r. I upon 2 pi r. So inversely proportional to r. So inside it is directly proportional to r, outside 1 by r. Okay. So this kind of variation, linear then hyperbolic. You remember similar kind of variation we studied when we had a insulating sphere having a volume charge density rho v. जब अपने पास एक इंसुलेटिंग स्फीयर होता था जिसकी वॉल्यूम चार्ज डेंसिटी रो वी होती थी, उसमें भी ऐसे ही होता था, अंदर लीनियर और बाहर 1 बाय आर स्क्वायर. यहां बस 1 बाय आर है. फॉर इनफाइनाइट शीट ऑफ करंट यू कैन रिमेंबर मैग्नेटिक फील्ड इज k by 2. K is the current density in vector form, half k cross an. Sir, how to take an? You remember when we took a sheet charge, I taught you how to take the direction. How did you take it? Suppose the sheet charge was z equal to 5. The z coordinate of point was 8. ठीक है. आप समझिए, जब आप शीट चार्ज ले रहे थे तो मान लो शीट का जो इक्वेशन है, जो शीट का पोजीशन है, वो है z equal to 5, और जहां पे निकालना है इलेक्ट्रिक फील्ड, that was z equal to 8. So I told you subtract the z coordinate of the point and the sheet. So 8 minus 5 k cap. So k cap was the normal. Same thing here. Subtract the coordinate of the point and the sheet. That will give you the normal vector. Normal vector क्या होगा? शीट से पॉइंट का वेक्टर. तो पॉइंट का कोऑर्डिनेट माइनस शीट का कोऑर्डिनेट. ओके. But what if it is a thick sheet? Thick sheet माने where current is inside the sheet also. Where current is inside the sheet also. Here I have a volume current density J. Then beta, inside the sheet I will get Jx by 2. Outside the sheet I will get Jd by 2. शीट के अंदर Jx by 2 आता है, where x is the distance from the center of the sheet. Outside the sheet Jd by 2. D is the thickness. बेटा देखो, आप पूछ रहे हो इतने बेसिक की जरूरत है क्या? बिना बेसिक के, और बेसिक क्या फॉर्मूला तो अभी भी मैं बता ही रहा हूं, बट कॉन्सेप्ट समझा के बता रहा हूं ना, बिना उसके कैसे रिवीजन हो सकता है। और अगर एक पूरी यूनिट आपकी एक सेशन में कवर हो जा रही है, इससे फास्ट जाने का कोई सेंस भी नहीं है। नाउ इन केस ऑफ सोलेनॉइड, व्हाट इज सोलेनॉइड? व्हेन वी वाइंड अ वायर over a material, that material can even be air, okay? When you wind a wire having n turns spread over L length, so there are n turns which are spread over a length L, then the magnetic field inside the wire is Ni by L, okay? Or N into I, where small n is the number of turns per unit length, capital N is the total number of turns. Similarly, if you make a circular solenoid, that is, you are winding the wire over a donut, then it is called as toroid. Toroid have two radius, the inner radius B, the outer radius C. So you take a mean radius, the radius passing through the center. The mean radius is called as B plus C by 2. Okay? So that is called as the mean radius. So we are assuming that magnetic field is passing through the center of the loop. So the radius of the field path is called mean radius. So how much path does the magnetic field have to travel? That is the length 2 pi r, pi into B plus C. So number of turns per unit length, n upon pi B plus C, number of turns by circumference. अब की बार जो लेंथ है ना वो circumference बन गई pi into B plus C. And then beta h is ni, तो n into I. Okay. Now diameter, the thickness will be C minus B, which is equal to 2a. इसको हम 2a बोल रहे हैं. तो cross sectional area is pi by 4 d square. D is the diameter, which is the thickness C minus B. आप ये समझिएगा, इसके अंदर भी ना ऐसे सर्कल बन जाता है for the cross section. The diameter of this circle is outer radius minus inner radius C minus B. That helps in figuring out the cross-sectional area. Now this is about production of field. Now because of magnetic field, there is a force on a moving charge and force on a current carrying conductor. So let's talk about that force. Now beta, electric field can apply a force on a stationary as well as a moving charge. But magnetic field only applies a force on a moving charge. So Lorentz was a scientist that gave the total force on a charge. Due to electric field, QE, due to magnetic field, QV cross B. So V is the velocity of the charge, B is the flux density. So that gives you the total charge. Now how to find the direction? Simply take the cross product of V and B or use the Fleming right hand rule. This is velocity, this is magnetic field, this is the force. The first finger velocity, second finger the magnetic field, thumb is the result of the cross product, that is the force. And even in every cross product beta, हर cross product में you can make use of the Fleming right hand rule. So the first finger will be the first vector, the second finger will be your second vector, and the third your thumb will be the result. Thumb क्या बताएगा आपको? Result बताएगा. Now, if the current carrying conductor is there, then even when the conductor is carrying a current, the charges are moving inside the conductor. So those charges will experience a force. And that is why a current carrying conductor will experience a force inside a magnetic field. Just like a moving charge experience a force inside a magnetic field, when a conductor is carrying a current, because the charges are moving inside the conductor, it will also experience a force. The force on a current element is IDL cross B. IDL is the current element, B is the flux density. If you want the total force, you take the line integration. What is the force between the two current element? So basically, when there are two current carrying conductor, one of them will produce a magnetic field and other will experience a force due to magnetic field of the first one. The force is mu I1 I2 by 2 pi d Newton per meter. That is force per unit length. Now, if both conductors are carrying current in the same direction, force is attractive. If they carry current in opposite direction, force will be repulsive. So just like we talked about energy density in electrostatics, half d dot E, half epsilon E square or half d square by epsilon. Same energy density you can define in magnetism. Half B dot H, half mu H square, half B square by mu. Replace epsilon by mu, D by B, E by H. E को H से replace करो, D को B से, epsilon को mu से. You will get the energy density, and volume integration of energy density gives you the energy. Now, when you talk about the motion of a charged particle inside a magnetic field, I told you whenever a charge is moving in the presence of magnetic field, it experiences a force. So that force will affect its motion. So if the velocity is parallel to magnetic field, the force will be zero. If the force is zero, magnetic force is zero, so the motion is not affected. Motion unaffected rahega. If V is perpendicular to B, then force QV cross B will become QVB or QUB, where U is the initial velocity. Now this force will be perpendicular to velocity and magnetic field. Whenever force acts perpendicular to velocity, it only changes the direction of the motion, not the magnitude of velocity. जब भी फोर्स परपेंडिकुलर आता है वेलोसिटी के, तो वो मोशन की दिशा बदल सकता है, वेलोसिटी बढ़ा या घटा नहीं सकता. Neither it can accelerate nor deaccelerate, it can change the direction. So such a force is required in a centripetal motion, or sorry, in a circular motion. Such a force is called centripetal force. So centripetal force always acts towards the center of the circular path. जब कोई चार्ज सर्कल में मूव करता है तो उसके सेंटर की तरफ जो फोर्स लगता है वो सेंट्रीपिटल फोर्स होता है. इट हेल्प्स इन द सर्कुलर मोशन ऑफ अ चार्ज. So what is the radius of the circular path? mv by qb. M is the mass of the charge, v is the velocity, q is the charge, b is the magnetic field. Time period becomes 2 pi m by qb. So now if you see, the time period is independent of velocity. Time period independent of velocity होता है, ठीक है. But what if a velocity is at angle to B? So break the velocity into two parts, perpendicular to B, along B. Now the velocity along B does not get any force due to magnetic field. ये जो V cos theta आ रहा है, B के parallel आ रहा है, इसकी वजह से कोई फोर्स नहीं लगेगा. So this will remain the same. But because of V sin theta, which is perpendicular to B, you will have circular motion having the radius mv sin theta by qb, time period 2 pi m by qb. Now because there is circular motion and also the charged particle is moving ahead with a velocity which remains constant, unaffected by B. सर्कुलर मोशन भी है और आगे भी बढ़ रहा है बेटा, क्योंकि इस वेलोसिटी पे B का असर नहीं पड़ता है. तो देयर विल बी अ हेलिकल पाथ, दैट इज पाथ एज अ स्प्रिंग. स्प्रिंग की तरह पाथ होगा. So the distance between the two circles is called the pitch, which is v cos theta into time period. दो सर्कल्स के बीच का जो डिस्टेंस है उसे पिच कहा जाता है. वो कैसे निकलेगा? v cos theta into टाइम पीरियड. एक सर्कल पूरा करने में कितना टाइम लगा और कितनी वेलोसिटी से चल रहा था, इस प्रोडक्ट को हम कहते हैं पिच. Okay, is that clear? Now beta, just like we define electric potential, we also define magnetic potential. So what is the magnetic flux density? First of all, the magnetic flux density is the number of field lines passing perpendicularly through a area per unit area, that is divided by area. So that is equal to the flux density. Now B is written as mu H. So what is the magnetic flux? Magnetic flux tells you how many lines are passing an area normally. So what is the difference between flux and flux density? Flux density is telling you number of lines passing normally per unit area. साइक्लोट्रॉन में भी यही होता है, सर्कुलरली एक्सेलरेट कराया जाता है पार्टिकल को, ठीक है. सो मैग्नेटिक फील्ड लाइंस पासिंग पर यूनिट एरिया इज द फ्लक्स डेंसिटी, टोटल लाइंस इज द फ्लक्स. So flux is the surface integration of the flux density. ds vector is the area vector, magnitude equal to area, direction perpendicular to area. So now beta, in the electrostatics, the Gauss law suggested that the surface integration over a closed surface for electric flux density is the charge enclosed. In magnetism, it comes out as zero. That is Gauss law of magnetism. Because B is solenoidal, it exists in a closed loop. So when you take a closed surface, the number of lines that enter the closed surface is same as the number of lines leaving the closed surface. So the net flux comes out as zero. जितनी लाइनें क्लोज सरफेस में घुसेंगी उतनी ही लाइन क्लोज सरफेस से निकलेंगी, तो रिजल्टिंग फ्लक्स आपका जीरो ही आने वाला है. And what is the physical implication of this? That magnetic monopole do not exist. That means whenever you talk about magnet, the north and the south pole always exist together. So like in a electrostat, you say the net charge enclosed is 2 coulomb. In magnetism, there is no net charge because north and south will always cancel each other. Magnetism में north और south अलग अलग नहीं आ सकते, तो नेट मैग्नेटिक पोल हो ही नहीं सकता. नॉर्थ और साउथ एक दूसरे को काटेंगे तो नेट पोल स्ट्रेंथ विल बी जीरो. तो कर्ल ऑफ एच इज इक्वल टू जे. दिस इज द एम्पियर लॉ. नाउ बेटा वी टॉक अबाउट द स्केलार पोटेंशियल जस्ट लाइक वी डिफाइंड फॉर इलेक्ट्रोस्टैट. E is minus gradient of V. Okay, so for the charge free region, we defined del square V 0. This was the Laplace equation. Electric field was conservative, so the line integral of electric field over a loop was 0. And how to find the potential difference V2 minus V1? Using line integration of electric field. This integration is independent of path. Path independent hota hai. Similarly, the scalar potential is analogous to vector magnetic scalar potential is analogous to electric scalar potential. You write H as minus gradient of Vm. जैसे E लिखा minus gradient of V, ऐसी H is minus gradient of Vm. Now Ampere's law says del cross H is V. Now beta, del curl of gradient is always zero. कर्ल ऑफ ग्रेडियंट तो जीरो आता है, तो हम अच्छे से जानते हैं, नल आइडेंटिटी है. So that means you can write H as minus gradient of Vm only if J is zero. क्योंकि curl of H should be J. But if you write H as minus gradient of Vm, then curl should be zero. So it only exists in a current free region. Just like you said, in a charge free region, del dot D will be zero. इसको कंपेयर किससे कर सकते हो? इलेक्ट्रोस्टैटिक से, जहां पे चार्ज फ्री रीजन की बात हुई थी, जहां लैपलास इक्वेशन की बात हुई थी. ठीक है. बट इन मैग्नेटिज्म द डाइवर्जेंस ऑफ बी इज ऑलवेज जीरो. तो डाइवर्जेंस ऑफ म्यू एच इज जीरो. So if mu is constant, you can say divergence of H is zero. Now beta, H is minus gradient of Vm. Minus gradient of Vm. So del square Vm is zero. This is similar to the Laplace equation in electrostatics. There you have a charge free region and homogeneous dielectric. Here you have a current free region and homogeneous magnetic material. जब आपने mu को constant करके बाहर निकाला ना बेटा, म्यू को कांस्टेंट करके, तभी आपने ये एज्यूम कर लिया कि मटेरियल इज होमोजेनस. दैट मींस म्यू डज नॉट डिपेंड ऑन द कोऑर्डिनेट. So when you wrote E as minus gradient of V, this was the method of finding potential difference or the EMF. Similarly, when you write H as minus gradient of Vm, this is the method of finding the potential difference, and H dot dl is known as the MMF, magnetomotive force. So just like EMF produces current, MMF produces magnetic field. अब समझ गए, सारी चीजें सेम डिफाइन कर दी बेटा. So electric field is minus gradient of V. Similarly, magnetic field is minus gradient of Vm. Just like you find the potential difference using line integration of E, you find potential difference using line integration of H. Okay. Now we come to the vector potential. So magnetic scalar potential is similar to the electric potential. But magnetism always says one thing, that B is solenoidal or divergence is zero. Now beta, divergence of curl is always zero. This is a null identity. That means B can be written as del cross A, where A is called magnetic vector potential. So now beta, what is the Ampere's law? Del cross H is J. If you write B, you have to write mu J. Why to write mu J? Because B is equal to mu H. Now B can be written as curl of A. So curl of A is mu J. How to write curl of A? That is gradient of divergence minus Laplacian of A vector. ये gradient of divergence minus Laplacian of A vector आता है. This is the vector identity. Now Laplacian of A vector is by taking the Laplacian of each of the component. ठीक है, एक वेक्टर के अंदर क्या होता है, तीन अलग अलग कंपोनेंट, तीन अलग अलग स्केलार फंक्शन होते हैं. हर एक का लैप्लेशियन लेने से पूरे वेक्टर का लैप्लेशियन आता है. नाउ बेटा, फॉर स्टेडी करंट डेल डॉट ए विल बी जीरो, so only the second term will remain, minus del square A is J. Now this is del square AX, which will be minus mu JX. I'm comparing the X, Y, Z component on both sides. Minus del square AY is mu JY, del square AZ is mu JZ. This is similar to Poisson equation. Del square V is minus rho V by epsilon. Instead of volume charge density, you have volume current density. Instead of epsilon, you have mu. Okay, instead of epsilon, you have mu. So you can write this is the equation of different components. But vector potential के बारे में basic याद रखना, that B can be written as curl of A, where A is the vector potential. Now what is magnetic dipole? In the starting bit I told you, in the Oersted experiment he observed that the current carrying conductor was able to align the iron fillings in the same way that a magnet does, which means a current carrying conductor behaves like a bar magnet. Bar magnet has two poles, north and south. So a current carrying conductor or a current carrying loop will behave like a magnetic dipole, that is north pole and south pole. How to decide R for different coordinates in A equation? R माने ये कह रहे हो, R is the distance जहां पे आप ये करंट एलिमेंट ले रहे हो वहां से उस पॉइंट का जिस पे पोटेंशियल निकालना है. ओके, तो R is the position vector of the point where you are taking the current element from that point to the desired point. ओके, तो R क्या है भाई, जैसे आप इलेक्ट्रिक फील्ड में लिखते थे Q by 4 pi epsilon R square, तो R होता था distance from the charge to the point. Here distance from the current element to the point. So magnetic dipole moment is written as current into area. The unit is ampere meter square. It is a vector quantity. How to find the direction? Curl the fingers of right hand in the direction of current in the loop. The thumb will give you the direction of dipole moment. So you can also write I into area vector, because area vector is also perpendicular to the loop. The direction of area vector also I have told you to find using the same way. Curl the fingers of the right hand along the curve. The thumb gives the area vector. So I into area vector, because the direction of area vector and direction of dipole moment are same. Now in electrostatics you said whenever an electric dipole is kept in the presence of electric field, it experiences a torque P cross E. Similarly, when a magnetic dipole is kept in the presence of magnetic field, it experiences a torque Pm cross B. This principle is used in case of motors, PMMC instrument, to produce torque on the coil. Okay? So if current is anti-clockwise, the normal direction is outwards. That is the direction of dipole moment. Current anti-clockwise, area vector outwards, dipole moment. Anti-clockwise, area vector outwards, dipole moment. Okay? Is that clear? So area vector will be B cross A. Here area will be pi r square. Okay, pi r square. An cap. Okay. So here if it is clockwise, area vector will be A cross B. Clockwise, area vector will be half A cross B. It is a triangle. Anti-clockwise, half A cross B but outwards. Half A cross B but outward. Now beta, when a coil is carrying a anti-clockwise current, you can imagine that a north pole is being formed. When a when a coil is carrying clockwise current, we can imagine a south pole is being formed. Okay? So by the same concept of the electric dipole, you can write the magnetic field due to a magnetic dipole. So 2m cos theta, this is the axial, this is the equatorial. जो आपने सेम इलेक्ट्रिक डाइपोल में पढ़ी थी वही चीज को आप यहाँ पे भी कर सकते हो. ये इलेक्ट्रिक डाइपोल में आया था, P की जगह M आ गया, बस इतना है. ठीक है? Instead of P we have M. Now beta, whenever a current carrying loop is kept in a magnetic field, it experiences a torque. I already told you the torque, M cross B. M is the magnetic dipole moment, current into area. B is the flux density. So torque is M cross B. This principle is used to rotate the coil of a motor or even the coil of a PMMC instrument. What about the boundary condition? In electrostatics, you told ET1 equal to ET2. Here HT2 minus HT1 is K cross AN. K is the surface current density. Surface current density at interface. AN is the normal vector from medium 1 to 2. AN कहां से कहां तक है? Medium 1 to 2 है. Then you said dn1 minus dn2 is rho s. Here bn1 equal to bn2. यहाँ नॉर्मल में rho s आया था, यहाँ टेंजेंशियल में करंट डेंसिटी आया. यहाँ टेंजेंशियल बराबर था, यहाँ नॉर्मल बराबर है. So if k is 0, current free interface is there. ht2 will be equal to ht1. ht is h sin theta. Theta is the angle with the normal. And hn is the h cos theta. Now B is mu h, so mu1 h1 cos theta, mu2 h2 cos theta. So when you take the ratio, you will get mu1 h1 cos theta 1 is mu2 h2 cos theta 2. Then h1 sin theta 1. So when you take the ratio, tan theta 1 by mu1 is tan theta 2 by mu2. जैसे यहाँ आया था tan theta 1 by epsilon 1. तो अगर आप इनको साथ रखोगे तो आपके लिए समझना बहुत इजी हो जाता है. ठीक है? अलग अलग रखोगे तो थोड़ा सा याद रखना मुश्किल है. So if you see carefully beta, if you see carefully, the concepts are analogous in electrostatics and magnetism. बेटा A और B उन पॉइंट्स के डिस्टेंस है जिनके बीच में आप पोटेंशियल डिफरेंस निकाल रहे हो, और ये फॉर्मूला बिल्कुल इलेक्ट्रोस्टैटिक वाला ही है, बस इलेक्ट्रिक फील्ड की जगह मैग्नेटिक फील्ड है तो इसे EMF की जगह MMF बोला जाता है. बख्शी जी मैं वहां डिफरेंस नहीं समझा रहा था, मैं समझा रहा था जो क्वांटिटी आप इलेक्ट्रोस्टैट में डिफाइन करो एकदम सेम फॉर्मूला आप मैग्नेटिज्म में भी बना सकते हो. ठीक है? नॉर्मल बेटा सबसे पहले देखो नॉर्मल कंपोनेंट कैसे निकालो। पहले जो भी मीडियम दे रखे हैं, मान लो एक मीडियम दिया है z ग्रेटर देन 0 के लिए और एक z लेस देन 0 के लिए। तो अगर आपका मीडियम 1 है z लेस देन 0 और मीडियम 2 है z ग्रेटर देन 0, तो while going from 1 to 2 z is increasing, so normal will be az. So now you take the dot product with the an cap, that will give you bn. Okay, that will give you bn. And if the medium 1 is z greater than 0, medium 2 is z less than 0, then normal from 1 to 2 will be in minus az cap. अब आप वैसे लीजिए, तो नॉर्मल लेना है 1 से 2 के लिए, ठीक है। तो दीज आर द फॉर्मूलाज बेटा जो भी मैंने आज आपको बताया है, ठीक है। ऑल द फॉर्मूलाज आर हेयर। चलिए, come to this. A long straight wire carries 10 ampere. What is the field intensity at a distance of 0.1? हाँ, तो नेगेटिव आ जाएगा बेटा डॉट प्रोडक्ट। अगर फील्ड की डायरेक्शन से अपोजिट है तो नेगेटिव आ जाएगा। बस मेक श्योर कि नॉर्मल वेक्टर इज फ्रॉम 1 to 2। बस इतना मेक श्योर करिए। ठीक है, I/2 पाई। ठीक है, आंसर विल बी ए। अगला देखिए, अ टोरॉइड हैज अ मीन रेडियस 0.1 मीटर, टर्न्स आर 500, कैरीज 2 एम्पियर, म्यू आर इज गिवन, फाइंड द फ्लक्स डेंसिटी इनसाइड। कम ऑन, फाइंड द फ्लक्स डेंसिटी इनसाइड द टोरॉइड। देन बेटा n is number of turns by circumference, 2 pi into mean radius, current is 2, 1000 10 की पावर 4, and 2 test. Next, the force per unit length between two wire 0.05 meter apart carrying 10 ampere current in the opposite direction. बताओ भाई, what is the force per unit length? Now, since the medium is not given, assume it to be vacuum. They both are carrying 10 ampere current. 2 pi 0.05. So 2. 200 by 540. So 4 into 10 to the power minus 8. And because they are carrying in opposite direction, they will be having repulsive force. Next. A charged particle with charge velocity b is given. What is the radius of the circular path? Come on. What is the radius of the circular path? 91 by 8. So almost 12. A option. Answer will be A option. Very good. Magnetic dipole moment is placed. यार ये वाला क्वेश्चन इनकम्प्लीट. और टॉर्क का फॉर्मूला आपको याद रहना चाहिए, M क्रॉस B. Vector potential is given. What is the magnetic field? Basically, B it is asking, that is the flux density. If I give you the vector potential, find me the flux density. चलिए. आंसर विल बी ए. ठीक है, मैंने वही शॉर्टकट लगाया जो कर्ल का मैंने आपको बताया था ना, कि इफ द फील्ड कंटेन्स ओनली एक्स एंड वाई कंपोनेंट, इफ इट कंटेन्स ओनली एक्स एंड वाई कोऑर्डिनेट, मतलब इफ अ वेक्टर फील्ड इज सच दैट, देखो एम एक्स वाई आई प्लस एन एक्स वाई जे, देन कर्ल विल बी के कैप एल एन बाय डेल एक्स. समझ गए? This method I sometimes use to reduce the time of calculating curl. Both the components should only depend on x and y. There should be two components, I cap and j cap. Only these two. चलिए, choose the correct statements about Ampere circuital law. बताओ भाई, एम्पियर सर्किटल लॉ के बारे में. It is only valid for magnetostatics because in electromagnetism, the Maxwell named scientist modified the Ampere's law. It can be applied to any closed path. It requires symmetry for easy calculation derived from Biot-Savart. आया तो basic Biot-Savart से ये बेटा. The basic law is Biot-Savart. On the top of it, using the symmetry, you have derived the Ampere circuital law. Try the next one. What is true about the magnetic scalar potential? Defined when j is 0. Satisfy Laplace equation. No, not always बेटा. अभी आपने A वाले स्टेटमेंट में सुभादीप बोला only when j is 0. अभी आप कह रहे हो हमेशा. No, not defined where there is a current. तो A and B. Magnetic boundary condition at a interface with no surface current. Boundary condition at interface बेटा. A and B. Normal component of B is continuous. Tangential component of H is continuous. चलिए. Try this. This is a basic question based on vector field beta. देखो डेल डॉट बी minus sin x sin y minus sin x sin y. नाउ कर्ल ऑफ बी, मैंने आपको शॉर्टकट बताया ना, डेल बाय डेल एक्स ऑफ एन, दैट इज y कंपोनेंट, माइनस डेल बाय डेल y ऑफ x कंपोनेंट. Okay. For the first one, 10 sin square theta by r. Then sine square theta by r. So it will become r, the derivative will be 1. Non-zero. Okay, 1 by r square sine theta. In AR cap beta, I get 0 minus 0 minus r a theta. Now this will be non-zero. 0 minus 20 sine theta cos theta by r. So clearly it is non-zero. Non-zero आ गया भाई, ठीक है, बात ही खत्म हो गई. तो A is neither solenoidal nor irrotational. B is irrotational. B is not solenoidal. This is wrong. B is correct. ये option. डाइवर्जेंस है तो कर्ल ऑलवेज जीरो का नहीं, डाइवर्जेंस और कर्ल दोनों हमेशा साथ में भी आ सकते हैं. कर लो अंकित भाई, कोई दिक्कत नहीं है, बाकी क्रैश कोर्स से रिवीजन भी कर लो. अगला देखो, टू इन्फिनिट करंट फिलामेंट्स आर इन पैरेलल, दे आर सेपरेटेड बाय 2b, दे कैरी इक्वल करंट. नाउ व्हाट इज द वैल्यू ऑफ मॉड h बिटवीन द टू इनफाइनाइट फिलामेंट? बहुत इजी क्वेश्चन है भाई. I want the magnitude of the magnetic field when they are carrying the same current in the same direction at a point midway between the two current elements. निकालिए. Suppose this is I, this is I. Now, because of dot, the magnetic field will be anti-clockwise. ठीक है? So, one magnetic field downwards, one upward. तो H will be 0. They will cancel each other. दोनों का इक्वल एंड अपोजिट आएगा. They will cancel each other. Very good, Ronak. Consider the following statements, beta. Which statements are correct? Come on, everybody. Which of these statements are correct? If a vector field is curl free, a scalar potential may be defined which completely describes the vector field. अगर कर्ल जीरो है तो स्केलार फील्ड डिफाइन कर सकते हैं क्या? बोलिए, कैन वी डिफाइन अ स्केलार फील्ड इफ द कर्ल इज जीरो? Yes, that is what happens in electrostatics. If divergence free solenoidal, we can define a vector potential. For a general vector field, you need both the potential. तो all are correct. एक जनरल वेक्टर फील्ड के लिए स्केलार और वेक्टर दो पोटेंशियल डिफाइन किए जाएंगे. नाउ आई एम गिविंग यू अ H. द करंट थ्रू अ स्क्वायर ऑफ साइड 1 मीटर विद द कॉर्नर एट ओरिजिन एंड साइड्स कोइंसाइडिंग विद द पॉजिटिव x एंड y एक्सिस. आपको करंट बताना है बेटा एक स्क्वायर से. निकालिए. क्या आ रहा है भाई? -4 एम्पियर। चलिए देखते हैं। तो व्हाट वी कैन डू इज बेटा, वी कैन अप्लाई द एम्पियर्स लॉ. So I can find curl of H to find the current density. K cap minus del M by del Y. है ना? I told you the shortcut beta. So 12y square K cap. Now this is J vector. Now the region is described in the XY plane. Okay, as the square. So current will be surface integration J dot ds. 12. Now, square has a side 1. So y square is y cube by 3. So it will be 4 ampere. Not -4. The answer will be 4 ampere. Okay? Very good, Shadow bhai. Magnitude of magnetic field intensity at radius 2 meter from a long linear conductor is 1. What is the current in the wire? वायर से कितना करंट आ रहा है बताइए. तो H is I by 2 pi rho. Answer is A, 4 pi ampere. चलिए next, consider the following statement. HT and BN are always continuous? No. This is true if K is 0. BN is continuous, HT can be discontinuous. Correct. BN is discontinuous, but BT is continuous. No. All field component can be discontinuous. मेरे हिसाब से इसका only 2 आएगा. Okay. Answer should be only 2. Is that clear, beta? Answer will be only 2 because BN is continuous and HT may be discontinuous. अब देखो ये वाला क्वेश्चन मैं कराता हूं बाउंड्री कंडीशन का. देखो रीजन 1, अब देखना मेरे भाई, डाउट पूछ रहे थे. रीजन 1 ऑक्यूपाइज x लेस देन 0. रीजन 2 इज x ग्रेटर देन 0. तो इंटरफेस is x equal to 0. So normal direction is ax cap. ठीक है. So what is hn1? n1 is 4ax. What about t1? The remaining component. How to find the tangential component? Subtract the normal from the total. Now mu1 hn1 is equal to bn1, which is equal to bn2. So what is mu1? 6 mu naught 24 mu naught ax, because it is asking B. Okay. Then there is no current at the interface. HT1 is HT2 because K is 0. So what is BT2? The mu R is 5. Mu R is 5. So 24 mu naught AX plus 5 mu naught AY minus 10 mu naught. A option. Answer will be A. दोनों का सम आएगा, नॉर्मल प्लस टेंजेंशियल. चलिए टॉर्क निकालना है बेटा. वेरी इजी क्वेश्चन. फर्स्ट फाइंड द मैग्नेटिक डाइपोल मोमेंट, देन कैलकुलेट द टॉर्क. निकालिए. आया भाई आंसर? देखो द मैग्नेटिक डाइपोल मोमेंट, ठीक है, इट इज दिस, area is 10 centimeter square is 10 to the power minus 3 meter square. Now for finding the normal, I will take gradient upon magnitude of gradient, ठीक है? So when you take the gradient of a surface, this is the value, two I plus 6j minus 3k by 7. Now what is B? 0.6I, 0.4j, 0.5k. Now M cross B, I want to find the torque beta, I, J, K, 0.005 by 7 to 6 minus 3. Okay, so that is how you can find the torque. टॉर्क आ जाएगा, ठीक है। अब मैग्नीट्यूड चाहिए तो भाई निकाल लेना इसका मॉड। आगे बढ़ते हैं। नाउ प्लेन y इक्वल टू 0 इज सेपरेटिंग द टू मीडियम, y लेस देन 0 इज मीडियम 1, y ग्रेटर देन 0 इज मीडियम 2। ओके, ठीक है। नाउ यू नीड टू फाइंड B1 H2 B2। B1 H2 B2 बनाओगे इसको? बनाइए। हाउ टू टेक द डायरेक्शन ऑफ इट्स नॉर्मल। बेटा नॉर्मल के लिए विनय क्या करना होगा, ग्रेडियंट लेना होगा, एंड देन यू हैव टू सी द डायरेक्शन ऑफ ग्रेडियंट इज ऑलवेज आउटवर्ड्स, so then you have to see whether the medium 2 lies above the plane or below. If it lies below the plane, you have to take negative of gradient. Above the plane, take magnitude of take the positive direction of gradient. अगर मीडियम टू प्लेन के नीचे है तो माइनस ग्रेड फाई लेना, और ऊपर है तो प्लस ग्रेड फाई लेना होगा। So an cap is ay cap because we are going from y less than 0 to y greater than 0. So first of all तो बेटा b1 mu1 h1, mu1 is 3 mu naught 2ax plus 3ay plus 4az. Okay. Now what was the boundary condition बच्चों? देखो बाउंड्री कंडीशन हमारे पास क्या क्या थी। H1t minus H2t is k. We took it as k cross n. देखो आपको ना याद कौन सा रखना है बेटा, you have to remember in the vector form. तो 2 minus 1 is k cross n. बहुत सी बुक्स में जो है ना स्केलार फॉर्म दिया होगा, you have to remember the vector form k cross n. Okay? क्या याद रखेंगे, k cross n 2 minus 1. So you can say HT1 2AX plus 4AZ cross AY. X cross Y is Z. Z cross Y is minus X. So minus 8AX plus 9AZ. Now mu1 HN1 is mu2 HN2. What is HN2? .258. So H2 vector will be minus 8AX plus 2.25 AY plus 9 AZ. And B2 will be 4 mu naught H2. ठीक है, 4 mu naught H2. Clear हो गया भाई? This is the answer that you are getting. चलो, last question. Given the vector potential is rho square by 4 AZ cap, I need the flux. For flux beta, I need the vector. Sorry, I need the flux density. Now in cylindrical coordinate, what I need to do is, I need to calculate the curl of A. Because whenever vector potential is given, this type of question you can expect from vector potential, where you will use it to find the flux density. Aero cap. Now beta, this is B vector. DS vector also you have to take in the same direction, d rho dz a phi cap. E dot ds rho square by 4. Remove the minus sign beta, minus का कोई रोल नहीं है. 3 by 4, 15 by 4 Weber. Okay, 15 by 4 Weber. First find the flux density, then find the flux. Clear हो गया भाई? बोलिए, anybody having any doubts up to here? किसी को कोई भी डाउट है यहां तक? चलें फिर. So let's complete some part of assignment that we left yesterday. थोड़ा assignment discuss कर लेते हैं भाई. देखिए, the cross section of a cable is shown. Capacitance. So beta, this is a question that belongs to power system. This is the capacitance, or you can simply say cylindrical capacitor. Epsilon naught is 8.85 10 to the power minus 12. Epsilon r is 3.5. Length is 8 kilometer, so 8,000 meter. Log b by a, log 15 by 10. So log of 1.5 is 4. 3.8 माइक्रोफैरेड, ए ऑप्शन, ठीक है, 3.8 माइक्रोफैरेड, वेरी गुड. Two identical capacitor with identical dielectric slabs. Okay. Just a moment. Two identical capacitor with identical dielectric slab in between are connected in series. Now slab of one capacitor is pulled out slowly with the help of external force. At steady state, which statement is true? Now beta, both are in series. When you are pulling out the dielectric slab from B, the capacitance of B decreases. Okay. So capacitance of B decreases. So earlier beta, both capacitances CA equal to CB, QA equal to QB, VA equal to VB. Now, as we pull out dielectric slab, CB reduces. Now beta, as CB reduces, so what happens is the equivalent reduces, charge reduces, but voltage VA will decrease, VB will increase because total voltage is same. So now beta, charge is overall decreasing. So during the process, positive charge from B to A will flow. During the process, the charge of capacitor B is equal to charge of capacitor A at all instant. Charge same rahega beta because this is series connection. So answer should be statement 2 and 3 are true because charge on capacitor reduces. तो बैटरी एब्जॉर्ब्स चार्ज. भाई देखो सीरीज हो या पैरेलल, सीरीज हो या फिर पैरेलल, if मेरे बच्चों any capacitance decreases, the overall capacitance will decrease. Two hollow spherical conductor A and B are arranged in the figure. Conductor B is initially neutral, okay, and charge on A is 2 coulomb. After connecting, what is the potential of B? Let me check which ones are A and B. So this is A, this is B. So charge on A is 2 coulomb, B is neutral. Okay. Then after connecting, what is the potential on B? So after connecting beta, VA should be equal to VB. And the total charge of A and B should be 2 coulomb. So what is VB? QA by 4 pi epsilon into what? QA into 4 pi epsilon QB. अगर VA निकालोगे तो QA की वजह से तो अपना ही रेडियस लोगे. But what about QB? What about QB? For QB also, you will take the distance as the outer radius 4. Because QB is inside. Okay. What about VB? Because QA is outside, so you will take the outer radius. Because QB is inside, so you will take the radius of Q. Okay. Now it means beta, it means for VB, we are taking inside QB, तो यहां से 0 आ जाना चाहिए अपना. ठीक है. If you equate this, QB should be 0. QA should be 2. Okay. So that means answer should be. Okay, the answer should come out to be B. Two capacitors of 10 and 20 microfarad are charged to 40 and 30 volt. The plates of capacitor are shown with one wire from each capacitor free. The upper plate of 10 is positive, upper plate of 20 is negative. Now, an uncharged capacitor of 30 microfarad is connected. Then voltage of the 30 microfarad. Okay. So what is the charge on 10? 10 into 40, 400 microcoulomb. Always remember, beta, in such a scenario, the total charge of the plates connected together can be conserved because their charge does not have any place to go. जो प्लेट्स आपस में कनेक्टेड होती है ना, उनके टोटल चार्ज को आप कंजर्व मान सकते हो. तो सपोज बेटा दिस वोल्टेज इज V. So this charge will be 30V minus 30V. Okay. Then after connecting, suppose I take this voltage as V1 as V. Now I will start conserving the charge. I will say beta, first of all, the negative charge on this and positive charge on this, the total should be the same. So minus 400 plus 600 should be equal to 10V1 minus 10V1 plus 20. 600, 200 by 10 is 20. First. Okay? First equation. Then what we can say? This 30 microfarad was uncharged. Okay, the initial charge was 400 plus 0. The final is 10V1 plus 30V. So V1 plus 3V is 40. Okay. Now I just need V. Then you can apply one KVL also, beta. V1 plus V minus V2 is 0. V2 is V1 plus V. ठीक है. If you subtract, V will come out as 20. So answer should come out as 20 volt. ठीक है. ये बात समझ में आ गई कैसे हमने लॉजिक लगाया. KVL इक्वेशन यूज किया and the plates that are connected together, their charge should be constant. Their total charge should remain the same. This is an important problem from gate point of view, both network as well as your EMT. Now, for the above question, find the final sum of the plates on charge B and G. तो B and G का total charge बेटा 200 ही रहेगा. Remains conserved. A positive 2 coulomb charge is at the center of a spherical dielectric shell with inner and the outer radius. Dielectric constant is 2.5. Find the surface charge density on the inner surface due to polarization. ठीक है? So basically beta, I have two spheres. ठीक है? मेरे पास ऐसे दो spheres हैं. Now it is a dielectric shell or insulating shell. At center I have 2 coulomb charge. Now the inner radius is what? 4 mm and the outer is 6 mm. Okay. Now epsilon is 2.5. So okay. Now it is asking us the surface charge density beta. Do one thing. Assume that a negative charge gets induced here. ठीक है? So now beta, electric field in dielectric. Now beta, when you take the induced charge na, you have to treat the medium as vacuum. When we have already considered Q induced in dielectric, treat medium as vacuum. Yeah. Okay. If you do not consider induced charge, this will be the situation. So that means 2 minus Q will be 2 by epsilon R. So Q will be 2, 1 minus 1 by epsilon R. So 1.2 coulomb. Now sigma will be 1.2 by 4 pi R square, 4 mm square. ठीक है? 4 pi 4 mm square. So this will come out to be 5968.31 coulomb per meter square. अगर इंड्यूस चार्ज लेते हो ना, फिर आप उसको एक वैक्यूम की तरह ट्रीट कर लीजिए. क्रैश कोर्स तो बेटा इसको हमारे व्हाट्सएप नंबर पे इन्फॉर्म कर दो. अगर टेक को इशू है तो सॉल्व हो जाएगा. पूरी इलेक्ट्रिकल मशीन पावर सिस्टम की प्रीरिक्विजिट नहीं है, सिर्फ सिंक्रोनस का बेसिक. ये क्वेश्चन देखो एंड जस्ट गिव मी अ मोमेंट, देन वील कंटिन्यू. चलो, electric field between two concentric cylinders is given. Now beta, for finding the energy when electric field is given, the best method is, we are assuming free space, the best method is using the energy density. Okay. Now, how to find the energy? Use the volume. It is cylinder. So instead of rho, I am mentioning R, nothing more. Radius from 0.01 to 0.05. Okay. Then d phi 0 to 2 pi. Length is 1 meter. So 8.85 by 2 log R. So it will be log 5 into 2 pi into 1. So how much? 8.85 into pi into log 5. समझे एनर्जी कैसे निकालनी है? 44.74. That is the energy. Potential field in a free space is given. Find the electric flux density and the volume charge density. So first, electric field is negative of the gradient. So minus del V by del R. It is just a function of R and theta. So I will only take two terms like this. So 1 by R square is minus 2 by R cube. 120 sine theta by R cube. AR cap minus 60 cos theta by R cube. A theta. Now D will be equal to epsilon E. Okay. So I will take epsilon naught. Because permittivity is not mentioned na beta. Del dot D is rho V. R into 120 by R cube sin theta. अरे spherical है ना. L by del theta minus 60 cos theta by R cube. Okay, beta. So the rho V, if you take sine square theta, 1 sine theta will be cancelled. 1 by R is 1 by R square. Now sine theta cos theta, 30 sine 2 theta by R square, cos 2 theta. Okay, this will be the value. Now it is up to you beta. You can put the points. आप इसके अंदर point डाल सकते हो and you can find the value. Epsilon naught भी था ना बाहर. To epsilon. Now you can substitute the value of r, theta and phi. R, theta, phi की value आप इसके अंदर डाल सकते. ठीक है? क्लियर हो गया? When a point charge is enclosed between two conducting planes, two parallel, the number of images will be infinite. Yes, because theta will be 0. For two bisecting plane, the number of images will be finite as long as the angle is a sub-multiple of 360. That means theta is less than 360, or 360 by theta is n. तो स्टेटमेंट 2 इज ट्रू, पर दोनों स्टेटमेंट ट्रू है। पैरेलल प्लेन में थीटा 0 तो इनफाइनाइट चार्जेस। A point charge is placed at 5 meter from the center of a grounded conducting sphere of radius 2 meter. What is the surface charge density? Assume surface charge density is sigma. Now, what is the potential? So, because it is grounded, the total potential will be 0. So, see, the distance of the nearest point from the point charge is 3. So, 2 microcoulomb by 4 pi epsilon into 3 plus sigma. So, rather than sigma, take Q. अब Q ले लो. Plus Q by 4 pi epsilon. The radius is 2. This should be 0. So, Q will be 4 by 3 microcoulomb. So sigma will be Q by 4 pi r square. (16) 1 by 12 pi माइक्रोकूलम पर मीटर स्क्वायर। माइनस में आएगा पूरा। A dielectric rod of radius 10 millimeter extend from z equal to 0 to 10 meter. Polarization is given. Calculate the bound charge density. इसको skip कर दीजिए. You don't need the polarization numericals. Dielectric में इतना करने की जरूरत नहीं है. A metal sphere of radius 2 mm has a uniform surface charge distribution. The surrounding permittivity is epsilon naught 1 plus A by R. Find the potential in the dielectric region at R equal to 4 mm. The value of the charge on the sphere. आपको क्या निकालना है बेटा? पोटेंशियल निकालना है और आपको चार्ज का वैल्यू निकालना है जो कि आपको स्फीयर पे नजर आएगा. व्हाट इज द वैल्यू ऑफ चार्ज ऑन द स्फीयर? ओके, क्लियर हुई इतनी बात? पूछा क्या जा रहा है? चलिए, तो नाउ फर्स्ट लेट अस विजुअलाइज दिस. इट इज सेइंग देयर इज अ मेटल स्फीयर ऑफ रेडियस 2 mm. It has uniform surface charge distribution. Now permittivity is epsilon naught 1 plus A by R. So this surrounding region is charge free. Okay, आसपास का रीजन तो चार्ज फ्री है आपका. Now I can use the Laplace equation to find the potential, and value of charge on the sphere is 4 microcoulomb. तो चार्ज डेंसिटी तो निकाल ही सकते हैं हम बहुत आराम से. यूनिफॉर्म सरफेस चार्ज डेंसिटी इज 4 mm. ए का वैल्यू भी दे रखा है 4 mm. Now potential is a function of R. We will use the spherical coordinate. So beta we will use Laplace equation. Why? ये क्वेश्चन तो नहीं था, मतलब क्या हुआ रौनक भाई? Use Laplace equation because the surrounding is charge free. It is just a function of R. H2 H3 by H1. Now beta, because the derivative of a certain term is 0, You can cancel sine theta from here. You can say r square del v by del r must be constant. So del v by del r should be c by r square. ठीक है, del v by del r should be c by r square. बट एक प्रॉब्लम और है ना, एप्सिलन इज नॉट कांस्टेंट. एक प्रॉब्लम और है, एप्सिलन इज नॉट कांस्टेंट. नॉन होमोजेनस मीडियम, it is non homogeneous medium. If it is non homogeneous medium, beta, what we need to do? We need to go by basic. So we need to say del dot d will be 0, del dot epsilon e will be 0, del dot epsilon. So divergence of a scalar into a vector is this, minus now E is a function of our gradient of V, gradient of epsilon. Epsilon is also a function of R, epsilon naught 1 plus A by R. So it is minus epsilon naught A by R square AR. So minus epsilon naught 1 plus A by R, 1 by R square, del by del R square del V by del R. Okay. Minus gradient of V, gradient of epsilon, okay, into LV by. So basically, beta, I am getting a equation in del V by del R. मुझे एक इक्वेशन मिल गई del V by del R में. जैसे let me take del V by del R as M. Epsilon naught 1 plus A by R, del by del R square M, minus epsilon naught A by R square. Okay. So epsilon naught by R square I can take common. 2R M plus R square del M by del R minus A. ठीक है, एप्सिलॉन नॉट बाय आर स्क्वायर मैंने हटा दिया. नाउ बेटा फ्रॉम हेयर व्हाट आई कैन डू, 1 plus A by R, 2RM plus 2AM minus AM plus R square del M by del R plus AR del M by del R. Okay. So now beta you can solve this differential equation to find M. आप इस differential equation को solve करके M निकालिए. ठीक है. And then after finding M, this will be del V by del R. Then again integrate to find V. Again आप integrate करके V निकालिए, लंबा जाएगा. But that is how you need to proceed. 20 question कुछ और था. Let me just check. कौन सा लेक्चर है, लेक्चर नंबर 4 ना. 20 क्वेश्चन कुछ और था। चलो फिर एक काम करेंगे, कल हम लोग 20 क्वेश्चन से ही रिज्यूम करेंगे, ठीक है। अभी इसके आगे मैं नहीं करा रहा हूं, कल 20 क्वेश्चन से ही हम लोग रिज्यूम करेंगे। बाकी 21 तो हमने बना ही रखा है। ठीक है, कल फिर हम 20 क्वेश्चन से रिज्यूम करते हैं बेटा, ठीक है। आई विल रिज्यूम फ्रॉम क्वेश्चन नंबर 20 टुमारो, एंड टुमारो अगेन वी विल मीट एट 4 PM and we will discuss the last part of EMFT, that is Maxwell equation. Okay, चलिए, so thank you everyone. I'll see you all tomorrow at the same time, 4 PM again tomorrow. Thank you everyone, have a great day. और YouTube वाले बच्चों, आज शाम को 7 बजे हम लोग PYQ सेशन करेंगे मशीन्स का, और जैसा मैंने अपने प्रीवियस वीडियो में अनाउंस किया, प्राइजेस बहुत ही जल्द बढ़ने वाले हैं कोर्सेज के, तो अभी मैक्सिमम डिस्काउंट मिनिमम प्राइस पे आप लोग ज्वाइन कर सकते हैं। तो थैंक यू एवरीवन, हैव अ